So this is a talk about refactoring. But before we start talking about how to refactor, let's talk about how we all get into this position where we need to refactor. And this should look fairly familiar. You know, you work someplace and someone has an idea. So what we're going to look at today is we're going to have a pizza builder. You can click on toppings and it makes the little pizza you want. You get some sort of wireframe, some sort of concept. You write a little bit of code and you ship out a product. You know, and it's working. And you have just a little bit of time to feel good about yourself before the first change comes in. So in this case, we're going to pull the information about the toppings from an API rather than just having it hard-coded. And don't spend too much time trying to stare at the code. We'll go through it a little bit more. So you had a little bit of code. Maybe you're not exactly loving where it goes, but you like to start off just keeping things close. Code base goes a little bit more. Your application works, and you move on. You get to your next feature, so now we're going to be able to add something and remove something. You add a little bit of code base grows a little bit, and the application works. So in my experience, it's usually around the third or the fourth change that things start to go kind of off the rails. There's always someone on the team, almost always someone in marketing, and they come up with this super duper, it's very, very important that you get this feature done, but not important enough for them to tell you more than 3 days before they need it done. So you have to get it out by Friday. You say, okay, you cram in some code, it's pretty ugly, you don't really like it, but you figure you'll come back and you'll fix it when you have a little bit of time. Your code base grows, gets a little uglier, but the application still works. So look, there's our super important feature. All right, but you don't have time to refactor, of course, because the next change comes in, and the next change, and the next change, and the next change, and before you know it, you have this jumbled mess of code. Where you can't read any of this code. You can just kind of tell there's some problems here. First, it's super long, it's jutting all over the place, it's indented super deep. But let me tell you that the worst thing about this code, the absolutely worst part, is that it works. So we have our marketing modal, we can add toppings, we can check to see something's not available, we can ask a user if they want to save, we can do all sorts of things with this application. So you have to be really careful, you have to have a light touch because you have something working that's out there in front of customers and you don't want to mess it up. All right, so we're going to talk about something a little easier, the second law of thermodynamics. So I don't know how many people remember their high school physics. Second law of thermodynamics is this. The total entropy of an isolated system can never decrease over time. So visually it looks a little bit like this. You have something that starts off neat and orderly, and then just kind of descends into chaos. So I don't know if there's a better representation of code base graphically that I've ever seen. It starts off with the best of intentions, and before you know it, you're looking at it, thinking, what is going on here? It's just all over the map. So the interesting thing about the second law of thermodynamics is that there's actually some physicists who argue that it's not a true law in the sense that it has to always happen that way every single time. And there's this physicist named Maxwell, and he had this thought experiment of what if you had a high entropy system, so one on the left where there's red and blue, slow and fast, cold and hot, and they're all bouncing together, and you had a little daemon that sat above this system, and it had a little door, and so whenever something hot came by, it would open the door, hot thing would go to the right, whenever something cold came by, open the door, the cold thing would go to the left. You could actually reduce the entropy of the system. So I'm not a physicist, I don't know about how this works in the physics, I know that there are some discussions of it, but I like this concept. So when we have this giant code base, you have to resist the urge to just go in and start ripping things around, tossing it all over the place. Instead, you want to just kind of start to peel it off piece by piece, just to deal with it one at a time. All right, so that's what we're going to do. We're going to play the role of the daemon today. We're going to take this code and we're going to start to try and peel it off one by one, start to make it work just a little bit at a time. All right, so you all probably know me, I'm Joe. I stand up here a lot and talk. Here's my Twitter and all that good stuff, if you're ever interested in seeing what I have to say. And I write things at these places. Their publishers are not happy that I have that slide. All right, let's jump into the code. So one thing you may have noticed that was a little weird is that there was no React code that I showed you as I was starting. And the reason that is because this talk was originally written for a more general audience. So I'll show you some of the React parts in a little bit, but we really won't spend a lot of our time there. So this code base essentially has 4 public functions. We have our add toppings, our remove toppings, display marketing message, and init. All right, so we're just going to kind of go from the top down. So the first part, we're importing a couple images, and then we have two top-level variables. And so I'm going to accidentally call these global variables. I know they're not global, but sometimes I get tripped up. But really what they are, they're a way of storing state. You know, they're the variables that all the functions have access to that they can change. All right. The next function is the biggest one. This is the add toppings function. So let's break that down a little more. Add toppings, the first thing it does is it hits an API with a topping ID, and it gets the response about whether it's available or not. From there, if it's available, it updates the toppings array, so it increments the number of toppings we have. And then we have a check to see that if there's 3 or more toppings and we have not asked the user to save. So if we have more than 3 toppings and we haven't asked the user to want to save, then we flip the save bit and we run the callback with some information about the modal. Whether or not we do that, we're going to take those toppings and we're going to create them into a human readable string, and then we're going to return that human readable string. And that's pretty much the topping with the count in parentheses. All right, so if it's not available, we're going to call the modal with the modal config information, and then we are going to reduce the toppings into a usable string and return those. All right, so the next thing is remove topping. Remove topping is pretty simple. We take the current toppings array, make a copy of it, splice out the one we don't want, and then we take that whole thing and make it into a human readable string. So obviously you're starting to see some redundancies already. All right, next is display marketing message. Display marketing message takes a callback and a config, and it runs a timeout, and then it calls that callback with the modal information. Okay, all the way here off the screen, it's so big you can't even see it, is the init function, and the init function gets an API, gets a response, and then creates an array of pairs that we use to fill out the toppings options list. All right, so here is the React part. React part is pretty simple. We have 3 states that we're keeping track of. The marketing message, which really is, that's the modal, so just think of that as the modal. Then you have the options, and you have the toppings. So first off, we get the builder. The use effect to reset, that's more for testing purposes. We won't really talk about that too much. All right, but we have 2 other effects that run on startup. First thing we're going to do is we're going to call that display marketing message with the timeout of 1 second. And so the cancel part is if we were to unmount this component before that timeout finishes, we don't want to update the display layer. So that's what's happening there. The next effect is essentially calling the init to get the list of toppings. That will just run once on load. And then we have 2 kind of click handlers. One is the update, and if you click on the left side, if you recall that, it will call that update toppings function, which remember is a whole bunch of stuff, but at the end of the day, it will give us back our toppings, which we will then set the state. And handle remove will remove the toppings and then set the new state. And here's what we're actually rendering out, which is the modal, which if it's open, we'll use it. Otherwise, the options is the left, choices is the right. And I won't go too much into those. They're pretty much just some material UI components. I didn't do a whole lot with them. All right, so we have our code base, we have a problem, we have the will to make things happen. Are we ready to refactor? So I think the hardest thing about refactoring is kind of pushing down that urge to just jump in and go. Because I think we've all gotten in this point where you start to work on something, you start moving things around, and then you realize that you have no idea what's going on. It's all broken, you can't get it to work, you have to do a git reset, and then win a whole day of your time doing really nothing. And so remember, our goal here is that we want to just kind of peel it off piece by piece. We want to make sure that every action we take, we have a working product. Because the last thing we want to do is break that working product. So here's our code, kind of this jumbled mess. All these conditionals, all these functions, all these statements, all these branches are just kind of bouncing around in here, just being really nasty. And what we're going to do is we're going to find one that we want to work with. We're going to isolate it, figure out how to pull out a specific action from the rest of the code base. We're going to purify it, so as far as possible, make it so it relies only on the inputs and the outputs. And then we're going to start to combine them back together. So we're going to start to put the pieces back together. And now that we have them smaller and isolated and purified, we can make better choices about where different pieces of code live. All right, so now we know we have a plan, we have what we want to work on, we're ready to refactor. And no, because again, the first thing we want to do is make sure that we don't break the working application. Whoop, you didn't see that. So that was actually my best joke, so it's too bad that I kind of gave it away. So pretend you didn't hear anything either. All right, so before we do no harm, we want to make sure that we don't mess up anything that we're working on. So I have this little mantra I repeat to myself when I'm working on the code, And you probably have heard this mantra already, but whenever I'm refactoring code, I kind of just say this to myself. Because you don't want to ruin anything you're working on. That's the absolute worst thing that can happen. So how do we get around that? Well, we're going to have to write some tests. So I'm not going to go too far into the tests. Avi there, he gave a pretty good talk on tests. It's up on our YouTube channel if you happen to miss it. So we'll just kind of jump into some of the quick and dirty, just to give you a reminder. So we're going to write some tests that make sure that the way the user interacts with the page is consistent. All right, so here's a bunch of the testing library stuff pulled out, but really we're focused on this. We're going to render out the component, and then we want to make sure that somewhere we have options and somewhere we have custom order. So not a perfect test, but it does pretty good because it kind of captures this state. So that we're going to make sure that stuff on the left and the stuff on the right are there even before the API runs. We'll probably want to make a few tests to make sure that the information is in the correct order or that it's divided up. Maybe we'll use a snapshot. It doesn't really matter to me. The more important ones are making sure that a lot of the actions also work, that the actions do what we want them to do. So in this case, we're going to wait for the word onion to show up. That'll make sure that the API runs. Then we're going to click on the word onion, and then we're going to get the right-hand column. That's what that get by test ID does. And then we're going to check to see if the word onion appears there. So effectively, we're going to be testing this. Clicking, making sure that the information is showing up where we expect it to. So we're going to make tests for all this stuff. We're going to make tests to make sure all the modals show up, that they have the proper information in them, that you can click, that it checks to see if things aren't available. We'll just assume all that's happened. All right, so now we have our code base, we have a plan, we're ready to take them one by one, we got our test coverage. Now are we ready to refactor? And yes, now it's refactoring time. All right, so we're going to go through the plan once again. And this plan is not really, you don't really do one part and then the next and the next. It's a cycle. It's a cycle that you kind of just repeat over and over. So we're going to take the code, we're going to isolate out a piece that we want to work with, we're going to purify it as far as possible, and then we're going to start to combine it back together. All right, so let's start with isolating. Isolating at its core means trying to figure out what exactly a function, a statement, a conditional, what does it need to know to be effective? And if it doesn't need to know something, how can you pull that out? So the easiest one is looking at the API. So here's our init information, our init function. It's hitting an API, and it's parsing the JSON, pulling out the options, and it's doing a bunch of stuff. So here's one that's similar with the add topping. We're hitting a topping API, getting some information, doing a whole bunch of extra stuff. Now the little one looks like it may not be that bad, but the problem is that it actually has to know quite a bit about what's happening. It has to know, first of all, where your API is located. It has to know something about the structure of your API. It has to know what kind of data it's getting back. It has to do all these extra things. It has to know all these extra things about the system. And so if you have these scattered throughout your code base, it makes it a lot harder to work with because anytime something were to change that API, you have to go and fix it. So the easiest thing to do is just to isolate and pull those out. So we're just going to pull out the information about fetch toppings into its own little function. Now all it's responsible for is hitting that API and pulling out the data. Fetch toppings just takes the ID and it pulls out the data from the ID. So now when you update it, it's doing the same thing, but it doesn't need to know nearly as much. It needs to know that it's calling a function, but it doesn't need to know where that information is coming from. All it needs to know is that it's going to pull out that information in a certain structure. Yeah. So this isn't my idea. This is actually Corey's idea. I think he tweeted about it the other day, and I was like, hey, that's what I'm going to talk about on Wednesday. But what this does is it makes it so that things are a lot more isolated. So now inside of our tests, we can also do things like mock out that API folder. We can mock out the information we're looking for. We can hard code it if we need to just get around it for a sec. It makes it a lot smaller. So in terms of refactoring, isolating can often just be enough. Now a lot of times when I'm refactoring code, a lot of what I'm doing is not a whole-scale refactoring of the entire file. It's taking a single function, splitting it into two functions, and moving it around if I need to. Because if you think about it, we have all this code moving around, just bumping around. We've already taken one part and we've moved it out. We've made the entire file that much smaller, that much less complicated. We do two things, and we've already reduced the entropy level just a little bit. All right, so next thing we're going to do is we're going to purify. We're going to take some code, and we're, as much as possible, we're going to transform it into something that only relies on inputs and outputs. So what does that mean in practice? So in practice, we have this remove topping function, and we're taking the toppings, we're making a copy of them, splicing out the one we don't want, and then we're modifying them into usable strings. So the React has taken a functional turn lately, and especially with hooks, you don't really use a lot of classes anymore. And so the one thing I found that's been a little difficult about it is that a lot of the information is a little more hidden about what's outside the immediate scope of the function. So at a glance, you can't really tell that all this information is relying on something that's outside the immediate scope of the function. It's using a higher level variable. I don't think that's the right word, but it's using a variable that's in a different scope, a higher scope. And so the one thing that was nice about classes was you had a little keyword that kind of gave you a clue about what was happening. So you could glance at a function and see how many times it really was using something that was outside of its immediate scope. So the way to get around this is to try and keep those functions that refer to something outside themselves as small as possible and as few as possible. Because the thing is that we need to have state changes. Obviously, you want to have some form of state changes to get things working, but you really have to be careful about how often you change them. Because I've had some situations where I've had state changes that are really connected and really mixed in with each other, and it gets to the point that just a single extra change will just bring everything crashing down. I had a bug that resulted from a state change that I had written about 2 months earlier, but it took that long for it to manifest because it was just that buried. It was just that deep in. All right, so let's take this function and we'll purify it. So really, you can tell that this function does two things. We are we are removing our toppings, and we're creating the display name. So really, there's a pretty easy way to split this. We have the remove toppings, which is its own function, and we have generate display name. So remove toppings, as you can see, all it does is takes that information from the toppings, pulls out the one we don't want, and returns it. The generate display name takes an input, and all it does is modify that into a human readable string. It doesn't rely on any information outside of its scope. And so now that we have that, now we have something relying on its pure inputs and outputs, we have more options about what we can do with this code. We're not really stuck in this format anymore. So now that we have it isolated, we can decide what to do. Sometimes with pure functions, I'll pull them out into their own file. Makes it a little easier to test. Sometimes I'll leave them in if the file's not too big. It really depends on what you want to do. But one thing we can do, for example, is update the display layer. So here, before we had the remove toppings, which pulled in the toppings, promised resolved and updated toppings. It's kind of magic what's going on behind there. Now that we refactor it, we can move that generating display name out into the display layer. Because you could argue that this is more of a display concern, taking raw data and making it into a readable form. And you can tell that this kind of flows nicely because you could rewrite this if you wanted to, but the data just kind of flows into each function after the next function. First you get the toppings information, then you generate the display name, then you update the React state. I kind of find this hard to read, so I probably wouldn't do it. But if you have like a compose function or if you had a pipeline operator, you can just see the data kind of flowing down. All right, and so the other part is now that we have this nice isolated action that we have used in other parts of our code, we can go through and we can start to swap it out. All right, so what have we done so far? We took one function, split it into two, isolate out the part that can be pure, and pulled it out. So that leaves this other part. This other bit of code is not pure. It does make state changes. It does rely something on other than inputs and outputs. But I would call that pure enough. Because we have it isolated, so it only has one responsibility. All it's doing is changing the state. And now we can take that function that's pure, and we can go through the rest of the code and drop it in. So here's the really important part of having the test coverage, is every time you drop it in, you can see that it's working. You don't have to guess. You don't have to go back and rerun the page every single time. You can just see that it works exactly as you expect it to. All right. So next thing we're going to do is learn how to isolate and make something reusable. So actually try and make it a little more complex, more than just pulling it out. So to do that, we're going to look at the display marketing message, which again takes a callback, and then it generates display config, which is pretty much a bunch of CSS. So if we wanted to pull that out, the first thing we would do is realize that there's essentially two inputs that are coming in. So if we want to make this its own function, we just make a function called something like generate mobile config, where we pass in an image and a text, and then from there it would make the object and return it. Okay? And so after that, we can just update our code. It gets a little less complicated. You can see what's happening, and everything works. Now, the next thing we might want to do is to start to reuse that in other places. So we make modals about 3 times. And the first thing we're going to do is replace the one where we have the not available information. The problem is that there is one problem, and that is that this one doesn't have an image. So if you remember, our parameters kind of locked us in to where we had to pass an image in a text. So what this means is that now it's expecting certain things to show up, and if they're not there, it's going to create some issues. All right, so how can we get around this? I think this is a situation why it's a good idea not to try and refactor things really before you get them to the point that you have multiple examples. Because if that was the first one we made, and we made this function that pulls an image in a text, we're kind of locked in. And so instead what we want to do is keep parameters flexible. We want to make sure that there's options for any future code that uses it. So we're going to move those parameters out from a list and into a single kind of config object. So in this case, we're going to pass an object that has the image, the text, and top and left, which are going to be given default values. And then from there, we have our base CSS, putting in the top and the left. And then we're doing that kind of little magic there where essentially what we're doing is we're checking to see if there's an image. If it's falsy, it doesn't add anything to this object. If it's truthy, it spreads out the image as an object, essentially conditionally adding a field to an object. So if the image is there, it will be added to the object. If it's not there, it won't be added to the object. Cool. So now we have that working, and we can put it in there, reuse this code, and add in the text. Obviously, we have to go back and refactor that other one as well to take it to pass the object instead of a list of arguments. And the last thing we want to do is this ask the user if they would like to save and try and figure out how to reuse it here. So this one is almost exactly the same as the first modal config with one difference, and that is the width is slightly off. So one of the first things you may be tempted to do is add in the width as another property into that function, into that config object. Instead, what you should do is just plan on anything that you're not planning on. So really, the modal display does 3 things. It creates a base CSS object, adds an image, and adds a text. So anything that's beyond the image, the text, and the top and left will keep separate because they're used in 2 places. Anything that's left, we want to allow someone to be able to rewrite as they want. And so we're going to collect any extra information passed into that object, spread it out at the bottom, and update our CSS to whatever we want. So if we wanted to pass in transform, if we wanted to update the width, if we wanted to pass in CSS properties that weren't there before, that's all available. So one thing I didn't really have a chance to talk about, is when to refactor. So this one, we had a few different examples that we can start to see how they fit, how we've been using them. We can start to make things that are flexible that can handle all those different options. There's this really good article called Avoid Hasty Abstractions, which pretty much makes the point of this, which is just because you have something that you can make into an abstract function doesn't mean you should do it yet. You should really wait until you have a couple of examples before you start to go back and make those abstractions. And this isn't a new concept. Martin Fowler in the Refactoring book says he always waits until the 3rd time before he refactors. And I think that's a pretty good idea. So first time, leave it in. Second time, copy and paste, but feel kind of bad about yourself. 3rd time, go back and refactor. All right. So next up, we're going to handle the last big one, which is add topping. And you can already see that we've reduced the complexity quite a bit. Because before this didn't even fit on one screen. We had to go through piece by piece, whereas now the entire function fits onto one screen. So kind of roadmap of where we're at. We have our function. We had our functions that kind of perform the same action. We broke them apart. We made one piece that could handle all the different situations, and we can kind of pull that out. Again, that one was a pure function. If we wanted to put that in a utilities directory, we could do that. If we wanted to leave it in, we could also do that. All right, so everything's looking good. Okay, last step is combine. We've actually kind of been doing this so far, which is taking the pieces that we pulled out and making intelligent decisions about where we want to put them. Combining, though, means that you have the option of moving things around. It gives you the freedom to kind of rearrange pieces as you want, to pull them up higher if you want them to be reused by other components, to put them in other files if you need to make them more testable, to put them where they make the most sense. So let's look at our add toppings, the last really nasty piece we have here. So kind of going over this again, add toppings, what it does is fetch a topping, then promise results. If it's available, we update the number of toppings. If the toppings are greater than 3, we haven't asked the user to save. We flip saved to true, and then we generate a modal config and send that to the callback. And we then generate display names. Otherwise, we make a modal config saying this is not available, run the callback, and send the display name. Probably can't see it right about here, but you have to trust me. All right, so this one's kind of the greatest hits of all the problems. We have top-level variables that are being mutated by a function, so we're using something outside of its immediate scope. We have display concerns, so we're updating the display layer inside of a data layer, which to me seems like kind of a problem. And we have this one variable that is really only used by this one function, yet it's available to any other function. So there's a problem, there's a potential that that could be used poorly in the future and could cause some bugs that we don't expect. All right, so let's look again at the display layer, because this is where a lot of the action is going to be happening. So in our display layer, we're calling the add toppings. A whole bunch of stuff is happening behind us. We don't really know what, and then we're just taking some information and updating it. So the display layer is asking for information to be added, but it may itself mutate by having a modal pop up. To me, again, that seems a little off. All right, so let's kind of just go through this one by one. So first step, what can we pull out and isolate by itself without any extra work? And what I would do is I would pull out this part of just a little on its own. And the reason why is because pulling this out, the entire rest of the code will not have to be wrapped in a promise. We'll have that promise isolated on its own. So we can make a function called check availability, where it fetches the topping and then sees that the information is available. If it is, it returns that. Now, whether you want to do this in this particular file or whether you want to do that in the API layer, I think is up to you. Me personally, I always keep the API layers really, really simple. Hit the API, return the data, no destructuring, no manipulation. I've had other coworkers in the past who think that the API layer should just return the information in the format you want. It's really up to you. For this example, we're still going to keep the API layer flat and just destructure the information we need out of here. All right. The downside is we have to have that information about whether it's available passed in. So the function has gotten a little more complicated because we're adding an extra parameter, but it'll be gone in just a second. All right, so now let's combine. Now we can do things like pull this check availability out and put it in the display layer. Again, I don't know if you would consider that the right choice, but it is an option you have. You have the freedom to decide where to handle that. And the reason I like putting it there is because you can have the await happen, and then all the other information is nice and synchronous. You don't have to have the entire thing wrapped in an await or in a promise. So now we're going to check if it's available, and then we'll call add topping with the marketing message, the is available information, and the toppings. We'll get the updated information, and we'll run that set toppings function with the new data. All right, so everything has gotten a little smaller. The next step we're going to do is we're going to pull out this else condition. So for the most part, if you have a really big if condition, it can be really hard to read because you have to skim a whole bunch of material before you get to the error case. So instead we're going to pull that error case out so it happens early on. And all of this is a function that's going to just say generate the modal config. That's all it's going to do. It's not even going to check to see if something's available. Instead, what we're going to do is we're going to pull that available information out, and we're going to move that to the display layer. So that little piece of code we had to put in there is gone. It's back to the way it was before. All right, in our display layer, now what we're doing is checking to see if it's available. If it's not available, we set the unavailable marketing message in return. So the beauty part here is we don't actually have to run the set toppings. We're not re-rendering state, we're not re-rendering the component. And I guess we are because we're re-rendering the modal. But we're doing a few less manipulations. So this is an idea called failing early. And for the most part, I would encourage you to put your failure cases higher up and make them just really simple conditionals that you exit out of. And the reason that is because the failure cases tend to be smaller, so you can skim them. And that way you can kind of skim the problems and get down to the main part of what's happening later on in the function. All right, next thing we want to do is we want to pull out these impurities. First one we're going to worry about is the toppings. We're going to pull that out. So where add toppings is its own little function. All it does is it's going to take the toppings, copy with the new information, and update it. And it's going to return the toppings. Display layer gets changed. We check to see if something's available. If it's not available, we'll set the marketing message and exit. Otherwise, we'll add the topping, get the new toppings back, check to see if the toppings limit has been hit. If it has, then we'll set the marketing message. Otherwise, or whether we do that or not, we're going to generate the display name and update the set toppings. So notice something else that happened here is now all of the display concerns are happening in the display layer. We're not passing a callback that can update this state all over the place. It's going nice and down in order and just performing the actions it needs to. All right, so the last one is this little complicated piece where we want to ask a user if they have saved something they're working on, but we don't want to ask them more than once. So the problem here is this is some stateful information, but it's only used by one function. And we want to get that out of there. And the reason that is because once we add some information out there that can be mutated by other functions, we run the risk of future bugs where someone well-meaning changes that to do one of their other actions, and it's not what it was intended for. So we're going to do that by creating a closure. And this is a pretty old concept. It's been used in JavaScript a long time. Although I do have a coworker now who worked at JavaScript before they had closures, which was way back. And the way it's going to work is kind of like this. This is the plan we're going to follow. So we're going to create a function. This is similar to this one. This is more simple. And this function is called call once. And what it does is it's going to have a single variable called called. And it's going to return a function. We're going to check to see if that function has been called. If it has not been called, then we'll set that variable to true and we'll run the function. Otherwise, we'll return called. So now we have this variable here, and it's completely scoped to just this one function. We don't have to worry about anyone else messing with it. It's isolated to that specific place. All right, so if we were to pass in a function that returns hi, we call the first time it calls the function hi. After that, it will just say it's been called, and we don't have to worry about it being called again. All right, so how are we going to do that here? We're going to follow the same idea. We're going to create a function called setThresholdLimits that takes a number of limits, and we're going to set a variable of ask to false. Then we're going to return a new function. So we're going to create a closure around that asked variable. If we've asked the user if they want to save, we're going to return false. We don't want to bother them anymore. So that's a failing early case. Next, we're going to check our limits. So we're going to see if every limit has been reached. And so every is an array method that returns either true or false, depending on each of the items in the array. So we're going to call each function that gets passed in. If we have not reached the limits, then we return false. We don't want to ask the user if they have saved it. Otherwise, we'll set that to true, and we'll return true. So we'll ask the user once they want to save it, but after that, we won't ask them anymore. And so the way we'll actually implement it is we'll call setThresholdAlert. We're going to pass in a function that takes the toppings and see if it's greater than 3. And all that means is if we call with 2 toppings, it'll return false. If we call with 3 toppings, it'll return true, display that modal. And then every single time after that, if we call it 4, if we call it 5, if we remove a bunch of toppings and we only have 2, it will never call it again. We've created that closure. All right, so now we have our function where we can change it from toppings is greater than 3, and we change it to this where we instantiate that closure whenever the file is first imported. And then after that, it will call that function. Cool. All right, so now let's look at what we had before. Before we had this add toppings, which did all these different actions that were unrelated, well, they were kind of related, and it was all nested inside this promise, which had then nested conditionals inside nested conditionals. And we reduced it to a series of steps, each which had small responsibilities, which were easy to move around if we wanted to. And so we took our display layer and we made it to a series of actions which just go one by one. Check to see if something's available. If it's not, do certain actions. Then add the toppings and check limits, performing actions along the way. All right, so here we had our code on the left, big nasty thing, and here's the code on the right. Now, it may be a little disingenuous because we moved some of that into different code bases, but I think that's fine because some of those pieces you want to have reusable, and I think if they're reusable, you want to have them somewhere where they can be tested in isolation or pulled out in isolation. So here we had our code before, really nasty, a bunch of all these functions and actions and branches and statements just all bouncing here. And we moved them into different compartments. Where we had our data layer, which is just in charge of keeping track of the data, the utilities layer, which is just in charge of converting data from one point to another, and our display layer, which was in charge of taking that information and making it available for users. And everything fits nice and happily. All right, so last time, here's our 3 steps: isolate, purify, combine. Just kind of rotate through them. Every single time, you should be able to run your test suite and see things work. The beauty part of this is that if you are refactoring something and you have to get pulled off to another piece of work, to another action, you could come back in 2-3 weeks, know that everything is working, and just keep going from there. Refactoring doesn't have to be an all or nothing. It can be iterative. All right, so the last thing I want to talk about is when to refactor and who should refactor. And my answer to this is pretty simple. You should refactor all the time, and it should be done by everyone. And I think the reason that is because you kind of do have to refactor all the time anyway. Whenever you add a new code, you almost certainly will be changing something that's going on behind the scenes. And the reason that I think it should be done by everyone is that I think one thing we forget is that as individuals we write code, but it's only as teams that we write software. And so when you refactor code, especially code that's not your own, you start to gain ownership of it. You start to see it less as belonging to some person, this, that, or the other person, and more as belonging to the entire code base, the entire team. So on my project I'm on now, we have one function, or excuse me, one component that it hits an API, and while it's loading, it has a little spinner thing or a SVG placeholder, and then when it's done, it puts out the data. And that component has changed